Okay. We were doing chapter number 1. We'll do some numericals on that. And they may give you MCQ question on that basis. Okay. Write a question. A nut is opened by a nut, NUT. A nut is opened by a range of length, by a range, WRENCH, by a range of length 10 centimeter. Range of length 10 centimeter. Full stop. If the least force required is 5 Newton, if the least force required is 5 Newton, comma, the moment of force needed to turn the nut is that option A, first option 50 Nm, second option 0.5 Nm, third option 5 Nm, and B option 0. Okay. Tell me the answer. What is the answer? What is the answer? So, very simple we do. Moment of force formula is F into D. What is the force value given? Force is how much? F value is 5 Newton and distance is given how much? 10 centimeter. Centimeter we must change meter. Become 10 by 100. That is 0.1 meter. The moment of force formula we have F into D, that is 5 into 0.1. Answer is 0.5 Newton meter. Which is the correct option? A, B, C, D. Option B. Next question, right? A mechanic can open a nut. A mechanic can open a nut by applying a force of 150 Newton, 150 Newton while using a lever handle, of length 40 centimeters, 40 centimeters. How long handle is required? How long handle is required if he wants to open it by applying a force of only 50 Newton. If he wants to open it by applying a force of 50 Newton, right? Option A, first option. Force of 50, force of 50 Newton. That option A. First option is 1.2 meters. Second option is 12 meters. Third option is 1.0 meters. And the fourth option is 0.83 meters. 0.83 meters. Okay. What to do? Question says a mechanic can open a nut by applying a force of 150 Newton while using a handle of length how much centimeter? 40. And same nut he wants to open it by applying a force of 50 Newton. That means he is reducing the force, then the distance must be more. The distance must be more than the distance given out here. 40 centimeters. So I will do that in this question. We do that is F1 D1 is equal to F2 D2. This we will do. The same thing we are doing in two different ways. F1 D1 is equal to, but the moment of force is the same. We can do that is F1 D1 into which E. Yes. So F1 is the force. What is the force in the first case given 150 into distance given 40 centimeter. You change in meter, right? 40 by 100. F2 is given 50 and we have to find the value of D2. We can get answer now. 50 3 times will go, 0 0 will go. This is coming 12 by 10 is the value of D2. Therefore D2 value is coming 1.2 meter. So take this option. 1.2 meter. Okay, the next question. Then the same force we are opening by two different methods. We can add F1 D1 is equal to F2 D2 and find answer. One thing is unknown, we will find it. So this working in the exam time you need not to show, but just for your sake you can do it. Okay, next question. Next question, right? Uniform meter rule. A uniform meter rule is balanced horizontally on a knife edge placed at 58 centimeter mark, placed at 58 centimeter mark, when a weight of 20 GF is suspended, is suspended from one end, to stop. The weight of the rule is at option A 100 GF, second option B 42 GF, third option C 105 GF, and last option 60 GF. That is the question. Let us find the answer. So for this question we draw diagram in short way. Directly we draw. Let's see, there is a meter rule which is balanced at 58 centimeter mark. 50 will be here, and balancing point is here. Here is the balancing point. You can write 58 centimeter here. Is balancing at this point 58 or there 58 mark. 58 centimeter mark means is balancing over, but it is balancing by keeping a weight at how much centimeter distance? At one end, either here or here. Which side you should keep the weight? Here or there? Which side? In order to balance it. This is 0 centimeter mark, this is 100 centimeter. Which side you should keep the weight in order to balance it? At 0 centimeter mark or at 100 centimeter mark? Think. Weight of the ruler is acting, just see, weight of the ruler is acting where? At 50, no, weight of the ruler will act at the center of gravity is here. W is acting here already. You want to balance this W. So this W will be balanced by keeping a weight on the other side. No, then only you can balance. If you keep it here, then both the weights will be same side of the turning point, pivoted point, then you cannot balance. You have to keep it the other side, this side, then only you can balance. No, like in the balance, physical balance, one weight is here, one weight is here. No, then you balance. So to balance this, you must keep it somewhere here, this side. This side you have to keep it here. What is the value of weight given which you are keeping it to balance? What is the weight value? How much weight you are keeping? 20. So write here 20 GF. Just draw the diagram and find answer. Write here W into this distance from here to the distance. How much is the distance coming? W into from the pivoted point we take the distance. This distance is how much? 50 and 58. How much is the distance? 8. This side at 20 into how much is the distance? 58 to 100. The distance is 100 minus 58 will become 42. Now cancel and get answer. 4 2s are 4 5s are 2 and this will go 21. Therefore W value will come multiply 105 here. Which is the correct option choose? That is weight of a uniform meter rule will be acting here at the center of the 50. Okay, the next question. Next question is right. A uniform half meter rule. A uniform half meter rule. A uniform half meter rule is balanced. At 20 centimeter mark. 20 centimeter mark by keeping a weight of 100 gf at its one end. Full stop. The weight of the rule is okay. Right, option A 40 gf. Second option 125 gf. Third option 100 gf. Fourth option 150 gf. Okay. So the question says what? Uniform half meter rule. So we'll draw half meter rule. Half meter rule will be from 0 to 50. We'll mark here 0 here, 50 here, the last point. Where will the weight of the ruler be acting? Weight of the ruler will act here at the midpoint, that is 25. This is W. W is acting here. Weight of the ruler is acting here. W is acting here. Where it is pivoted? At what distance point it is pivoted? Check the question. At what point it is pivoted? Balances at what centimeter mark? 20 centimeter mark. Balance point is 20. Here is the pivoted point. Here you can mark pivoted point. By keeping a weight, you have to keep a weight of how much? 100, no? Yes, sir. Where is the weight 100 situated? 100 will be situated where? At one end. Here or here? This side? 0. Then only can balance because already one weight is already here. To balance this, you must keep something this side. That means you are keeping the weight of 100 gf here, this side. Now we do like this 100 into this distance. From here to there, what is the distance? 0 to 20. 20 W into 5. Now we get answer. First option was 400 of here. First option was 400. Please cancel. Okay. W value is coming how much? 400. First option was 400. So what is the answer coming here? 400. We will take this option. Write a question. A uniform meter rule W, capital W, is balanced horizontally at 60 centimeter mark by keeping a weight M at 90 centimeter mark, at 90 centimeter mark. Full stop. Which of the following option is correct? Which of the following is correct? Just like which of the following is correct? Right, first option, right? A equal to 3W, W is equal to 3M. Option C, W is equal to 2M. Third option, M is equal to 2W. Now let us check which of the answer is correct. So draw a diagram and obtain the answer. Question says a uniform meter rule. We will draw a uniform meter rule first. According to the question, we proceed like this. This is 0, this is 100. Weight of the ruler is given. Weight of the ruler is given W. So W will be here 50. W will be here. W is acting here. This one is balanced at what centimeter mark is given in the question. Is balanced at 60 centimeter mark. 60 centimeter mark will mark the balance point 60 by keeping a weight of M at 90 centimeter mark. The weight is M over here. The weight is M at 90. This one is balanced. The meter rule is balanced by keeping a weight of M at 90 centimeter mark. Oh. Now we have to check which of the relation is true. So we will do that W into how much 50 to 60. How much is the value coming? 10. This is like M into the distance 60 to 90. The distance is coming 30. This will go. We will have the second W is equal to 3M. Which is the correct option? W is equal to 3M, the second option. If they ask you which of them is bigger, W is bigger or M is bigger, which one is bigger? W is 3 times of M. W is 3 into M. If M is 100, then W will be 3 into 100, 300. No? W is bigger. W is bigger. The weight of the ruler is bigger. And we know by the distance of this distance is smaller, no? When the small distance is less, the force will be more, no? And here the distance is more, 60, 20, 30 is the distance, and this will be less. From the distance also you will come to know which is bigger, which is smaller. Understood? Okay. Next question. Next question you write. A physical balance has its arms of length 60 centimeter and 40 centimeter. 60 centimeter and 40 centimeter. The weight kept on pan of the weight kept on pan of longer arm. The weight kept on the pan of longer arm will balance an object of weight 100 GF kept on the other pan is right. Option A, first option 150 GF, second option 50 GF, third option 66.6 GF, third option 33.3 GF. Okay. Let's draw the diagram in our sheet. So they are seeing there is the physical balance. You can just know the physical balance. Normally, the physical balance, the fulcrum will be pivoted point will be exactly midway, but this is different type. One is longer arm, one is shorter arm. They are saying one side is given arms of length 60 centimeter. From one side it is 60. This is 0. This is 60. Other side it is 40. That means this will be 100 here. Like this. There are two pans here, one pan here and another pan is here in this. That is, you can take it this way. This distance is 60. This side is 40. You can take it like this also. This is 40. One is longer, one is shorter now. So the question says, what weight kept on the pan of longer arm will balance an object of 100 GF kept on the other pan. There is a object of 100 GF over here. What weight you should keep on the longer arm? That they are asking to find to balance the load. What weight you should keep here? This time we do this W into this distance is always 60. This side I write 100 into 40. Now I'll find answer. 0 and 0 will go. 2 3s are 2 2s are W value is coming 200 by 3. 200 by 3. When we divide, answer will come 66.6. This answer 66.6. Okay. Now the next question. Next question now. Okay. Now the next question is, right, a uniform meter rule, weighing 50 GF, 50 GF is balanced horizontally at 60 centimeter mark, by a weight of 200 GF. Stop. Right. The weight 200 GF should be placed at right A, first option, 90 centimeter mark. Balance at what, 60 here? Here is the question. 60 here. The second option B, 80 centimeter mark. Third option, 75 centimeter mark. First option, what did you write? 90. Last option you write 100 centimeter mark. Yes. Now check what answer should come. What should be the answer? They say there is uniform meter rule. You can just make a rough diagram here. 0, 100 here. Okay, weight of the ruler is given. Weight of the ruler will act uniform, act exactly at 50. What is the weight of the ruler given? How much? 50 GF. Right now 50 GF is acting here. 50 GF is acting at 50 centimeter. The weight. And the ruler is balanced at 60 centimeter mark. Here is 60 centimeter mark. By keeping a weight of 200 GF. 200 will be somewhere this side, anywhere we don't know where we are keeping. Or suppose we are keeping a weight of 200 GF at a distance x, we don't know. We have to find the value of x. At what distance we are keeping, that we do not know. We have to find that. We'll do that in at 50 into how much there is. 50 into 50 to 60 is coming 10. This side is coming 200 into x. Let us find the value of x. 20 will go. 5 by 2 is the value of x. The value of x is coming 2 2.5. By keeping a weight of 20 GF, take the weight 20 GF also. Take the weight 20. By keeping weight 20 GF instead of 200 GF, no, please correct the question at 20 GF. 20. Okay. So answer comes what? 0, 0 will go. This will come 25. 2 and 50 will cut 25. X value is going to 25 centimeters. 25. So which is the correct answer now? Which is the correct option? From here the weight should come 25. This is 60 plus 25. How much is the answer coming? 85. No? Do you have that option? 85? Huh? What are the options here? Tell me.
90. 80 centimeter. 75. 100.
Last one 100. No, you write out 85. Last option instead of 100 write 85. 85 centimeters. So then which is the correct answer? 85. 85. No? From 60 here plus further x value we are finding 25. Then 60 plus 25. What is the answer? 85. So they will give the option accordingly. So previously I just guessed it. The correct option answer is 85 centimeters. Answer is 85. Okay. Now next question. Right, the resultant torque, of the forces, about the point O, capital O, as shown in the following diagram, So draw the diagram like this. Draw a diagram. Five Newton. This is 1 meter. This is 2 meters. This is 2 meters. Here is a diagram. Options will write down. First option 37 Nm. Second option plus 20 Nm. Third option minus 20 Nm. Last option is 0. Last option 0. Let us check the answer now. Write down resultant moment of force or the resultant torque equal to. Okay. We have to find the total moment of force. So what we will do, we will see clockwise and anti-clockwise. Clockwise moment will be negative and anti-clockwise moment will be positive. So I will first see, suppose this force from here I am seeing, this force will give what kind of moment? Force is 5, that 5 into the distance. What is the distance? The distance of this force from O, from the pivoted point. How much is the distance from here till here? What is the total distance? 2 plus 3, how much?
5.
So write 5. 5 into 5. What direction will it move? Clockwise or anti-clockwise? Which direction will it turn? This one, here is the pointer, this one is pushed this side. This will go like this, anti-clockwise. So anti-clockwise is positive. So positive sign you may not be understood. Plus, I have come to this now 6. 6 into how much should I get? 6 into the distance from the pivoted point. What is the distance from here till the distance is 2, right? 6 into 2. Yeah. 6 into 2. What direction? Clockwise and anti-clockwise. This one is giving what direction? This is the point. And this is clockwise, and this is pushed down here like this way. Here is the point of rotation. This is going like this now. This is clockwise. Clockwise is minus. Put a minus sign. Plus, I will come to this now. Right? 5 into this distance 1. What direction will it move? This is acting upward or upward. Here is the point. Here is the point. This line is pushed up. What direction it will go? Clockwise now. So put a minus sign. Plus this one. 4 into how much is the distance? From here to here, the total distance is 2 plus 1, 3. What direction will it turn? Here is the line, and this one is going like this. So this one is going down. That is anti-clock. So plus. Anti-clockwise is plus sign, no need to write, but minus sign we are supposed to write. Now we will simplify and get answer. This is going to be 25 minus 12 minus 5 plus 12. This and this will go. 25 minus 5 will come 20. 20 Newton meter. The answer is 20. Take care. Instead of given the sign out there, they may give clockwise and anti-clockwise. Plus is coming to that is anti-clockwise. Overall, this body will be turning in anti-clock direction. If the value comes 0, that means this will be in balanced position. That this will be horizontal. If the total moment of force comes 0, that means the body will not be turning. The body will be horizontal like this. Just now the value is going to be 20 Newton meter. That means the body is turning in the direction of anti-clockwise because of sign plus coming. Your answer may come with the minus sign. When answer comes with the minus sign, that means clockwise. So the diagram and the direction of rotation you understood how. Here is the line. When you push the line like this, what direction it will move? Like this now. Anti-clockwise. Here is the line. This is the line. When you apply force like this will go down like this clockwise. Here is the line. This will be pushed like this, so clockwise. And here is the line of this full line, and we are doing like this, that will give the motion in anti-clockwise. So accordingly, acting. Okay. Alright. So with this information, this chapter is over. Okay. This chapter is done over. These are the types of problems which they make even exams. Later on, I will make you practice all MCQ. Then this is the basic idea out here. Then you will get some ideas there. You got the formula. Moment of force formula is F into D. Couple formula is also either of the force, one of the forces into the total distance. And to balance it, we take the moment of both the sides. Left hand side moment, other side moment is equal. If a body is uniform, center of gravity will be exactly the midpoint, and at that point the weight of the entire body will be acting. So that is the whole idea of it. Okay, so today we do this much. Tomorrow we will start new chapter, work, power, energy. First I will finish the entire syllabus, then after that I will give you only MCQ. I will make you practice only MCQs from all the chapters together. Thank you.